Hey everybody, happy Tuesday to you. Hopefully you're doing pretty well so far early in the circles chapter. Yesterday you looked at angles, central angles, and inscribed angles, and of course I've got my notes up for that, so I don't think I need to review. And also it's not really going to be tied in too closely with what we're going to be doing today anyway. So let's take a look at what we're doing today. We're going to be talking about what happens when you have intersecting chords. Of course, you know that intersecting means that they cross at some point. If I have two chords that do not intersect, it would look something like this. And actually, we're going to take a look at a situation like this where this line segment stops at the end of the circle. But what if it keeps going? These two segments, if we extend them, would intersect, but that's a topic for another day. Today, the chords are intersecting. Reminder that a chord is just a segment that touches a circle at two different spots. And so intersecting chords just means we got a couple of them and they have a point of intersection. Now, the two big ideas today, the first one, big deal, idea number one is nice and simple. It goes like this. If these two chords intersect, the product of the two lengths of one chord is equal to the product of the lengths of the other chord. Well, it sounds kind of complicated, but really it just means this. These two parts, this chord right up here is cut into two pieces, A and B. The other chord is cut into two pieces, C and D. And it turns out that if these chords intersect each other at that point that separates the sections, the product of A times B equals C times D. And there's a lot of really cool math that goes into explaining why that is. A lot of it has to do with the Pythagorean theorem, but we're not going to worry about that. All we need to deal with is the fact that it's true. A times B equals C times D. And that's actually going to help you do most of the homework assignment tonight, or Wednesday night, or Thursday morning, or whenever you get around to the assignment. But for a situation like this where I've got intersecting chords, the equation is just going to be simply 6 times 4, these two pieces multiplied together, equals 8 times x, those two pieces multiplied together. So 6 times 4 equals 8 times x. 6 times 4 is 24. And if 24 is equal to 8x, we'll just divide both sides by 8 to get the 8s to cancel out. And x equals 24 divided by 8, which is 3. And that's it. That's how long that little segment would be right there. Situation like this, I've got a section that was cut into two pieces. And so this one is x and that one is x. And so the two parts are x times x, and the two parts of the other chord are 4 times 9. So 4 times 9 equals x times x. X times x is x squared. 4 times 9 is 36. 36 equals x squared, so x equals 6. We're not going to worry about negative 6, even though negative 6 squared is also 36. We're only dealing with positive side lengths, and so x equals 6. And that's it. So A times B equals C times D, where those are the sections of the chords. That's big deal idea number one. Big deal idea number two goes like this. If you have a radius to a circle, or I suppose a diameter to a circle would work also, but if it bisects a chord, if a radius bisects a chord, then those two segments must be perpendicular. Or I use the word conversely here. Remember from way back at the beginning of the year, the converse of that statement would be if a radius is perpendicular to a chord, then it bisects the chord, switching it around in the other direction. So if I've got a right angle, that means these two segments, not of the radius, but of the chord, those two are congruent to each other. And conversely, if these two segments are congruent to each other, then it must be perpendicular to the radius. So what this leads to is problems like this one that says I've got this line that goes all the way through the center of the circle. This section is 15, this part of it is 12, and I want to find how long this part of it is. Well, a couple things that we're going to have to use here. First of all, if this is perpendicular, that means that these two segments must both be the same. So these are both A. The other part of it is that big deal idea number one says this section, which is 17, times this section, which we haven't figured out yet, is equal to A times A. 27 times this equals A times A. The question is, how do we figure out what that is without knowing what A is? Well, if this is a radius, the radius of this circle must be 15. This length would be 15, and this length would be 15, and more importantly, this length right here must be 15 also. So if this part of it is 12, basically the question is 12 plus what gives us 15? And of course, whoops, 12 plus 3 is equal to 15. So that little section there must be 3. So if this part is 3, then the big deal idea number one says that 27 times 3 equals A times A. Remember again, these two must be the same because of this right angle. So this times this is A times A squared. And then the two other parts of this chord, 15 plus 12 is 27, and 3 is 3. And so we've got 27 times 3 equals A times A. 27 times 3 is 81. A times A is A squared. And if A squared is 81, then A must be 9. So that section right there is 9 units long. And really, that's it. I've got one more question that I want to do as more of a challenge question. As you're going through the assignment, when you see a question that has more than just one variable, in this case, I've got 3 variables, M and H and K. If you don't know how to do these problems, that's not a big deal. You can just skip those problems if you would like. But I know a lot of you are looking for a little bit more of a challenge. And so if you want to try one of those challenge problems, I've got an example here that we'll take a look at. 3 different variables, and that's a lot of stuff going on. But I've got a radius right here that is perpendicular to this chord. So right away I can say that if this section right here is 12, then this section over here must be 12 also. And then, since I've got 3 variables, well, I've got a lot of stuff going on here. We're going to have to try to figure out what exactly is going on. Well, first of all, I know that these two sections together, M plus K, those have to add up to H. So that's one thing that I can write down. I think I'm going to use this to say M plus H, nope, M plus, let's see, M plus K is equal to H. That's one equation that must be true. We also know, let's see, what else can we figure out? We know that this is a radius of the circle. K plus 8 is a radius, and M is also a radius. So K plus 8 must be equal to M. So I'll write that down. K plus 8 is equal to M, because those are both, again, radii of the circle. K plus 8 is one radius, M is another radius, and all radii have to be the same length. And then finally, we've got the big deal idea number one that says this section times this equals this section times this. So H times 8 must be the same as 12 times 12. Okay, so I've got 3 different equations. I should be able to figure out what my 3 variables are. Now, one thing I want to point out here is that in this equation, there's only one variable. 3 times h equals 12 times 12. I'll actually go ahead to the next slide because that's going to have that on there. So 8 times 8 equals 12 times 12. 12 times 12 is 144. And then divide both sides by 8 to get h equal 18. So at that point, I know that this segment right here is 18. And then because of what I said before, 8 plus k must be equal to m. Well, I don't know what either one of those is, so I can't just solve this by itself. And then k plus m has to be equal to h. I just figured out that h was 18, so I can plug that in there. But there's too much that I don't know. I don't know what k is or m, and so I can't figure out one without the other. And so what I'm going to do here, and this is a method from algebra that I think you guys learned about last year. If you didn't learn about it last year, you're going to learn about it next year. That says if 8 plus k is the same thing as m, then I could replace this m with an 8 plus k. Now again, I'm going to say that again, because if this is the first time you're thinking about this, it's kind of a strange idea. This equation says 8 plus k is the same thing as m, which means I can take the m from this equation and say, well, m is the same thing as 8 plus k, so let's just replace the m with 8 plus k. And so when I do that, plugging the 8 plus k in for m, I'm replacing that m with 8 plus k. Now I've got this new equation. And check out, in this new equation, only one variable. I just have k. In this case, k plus k is 2k. And then I've got 2k plus 8 equals 18, which, nice simple two-step equation. I'll subtract 8 from both sides of the equation. 8 minus 8 goes away. 18 minus 8 is 10. And then 2k equals 10. And so I divide both sides by 2. And so I find that k is equal to 5. So at that point, I know that h is 18. I just found that k was equal to 5. And I've got this other equation that says m is 8 plus k from way back when we did that. So now I know k is 5, 8 plus 5 is 13. And I've got all three. H is 18, k is 5, and m is 13. So again, if you want to skip those problems, if that seems crazy and complicated and you don't think you want to worry too much about that, I'm not going to worry about it either. But if you're looking for a challenge, try those problems in the assignment. And there we go. We'll move on to another section, more with circles and intersecting tangents. Actually is going to be a word that we're going to use that is a little bit different than the tangent we saw in trigonometry. But I'm getting ahead of myself. I shouldn't be doing that. As always, if you've got questions or comments, please let me know, and I will talk to you next time I talk to you. All right, bye-bye.